All right, I thought it'd be helpful to do a couple of these problems for you guys. We're going to talk about them in class, but this might be beneficial. First thing, rancher with 750 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. That image, this picture here, yeah, I don't think it's a really great picture. I think it might be more beneficial for you to kind of look at this from a bird's eye view. So there's our rectangular pen, and we're going to break this up into 4 regions. And it doesn't say anything about the size of those regions, so they can be equal, they can be different sizes, doesn't matter. Maybe we'll do that just to prove the point that it doesn't matter. But that's region 1, region 2, region 3, region 4. Now the idea is, and it doesn't say this in the directions, but we have to look at the notation. They want an area formula that is in regards to W, our width. So I want to let this be W. And then the idea of parallelism means that that's got to be W, that's got to be W, W, and W. So now if I have 750 feet of fencing, right now, whatever W was, however many feet that was, I've used 5 times that. Okay, so far, from my original 750, I've removed 5W of it. Okay, so that's what it leaves me with to figure out what is left over for that side and that side. That's what's left. This is the leftover, okay, for those 2 sides. And those 2 sides have to be the same. So what we do is we take the 750 minus 5W, divide that by 2, and now I've got my length, okay? So this is my length. Obviously here, this is my width. And if I want to find the area in regards to width, area in regards to width is length times width, but width being W. Length now is 375 minus 5 halves W. Kind of rewriting that, I get negative 5 halves W squared plus 375 W. Now they write it a little bit differently. You see my answer up there, or an answer that I should get. It shouldn't matter whether you type it that way or you type it this way. You're going to get the same result. Now the reason I like it this way is because we want to figure out what the largest possible total area is. So in order to do that, I need to find the value of W that provides it. So the value of W, remember from yesterday, or from class, is the maximum is always located at the opposite of B over 2A. So in this case, B is 375, so negative 375 over 2A. Well, 2A in this case is going to be multiply this number here by 2, it gives you just negative 5. So that ends up being 15, 60, 75. So W is 75. So when the width is 75, that's going to provide us a maximum area. All right, so I want to figure out then what is that maximum area when W is 75. So take that 75 and I'm going to plug that into the negative 5 halves W squared formula plus 375 W. All right, go ahead and calculate that. I'm going to save a little bit of time, but that will produce 14,062 and a half square feet. So what's nice about this is that W is the width in which this occurred, okay, the width in which the maximum occurred, and that maximum area then is 14,062 and a half. So we have ordered pairs here that are always W, comma, A of W, and that's what, again, come back up to there. That notation tells me that whatever my independent variable is, W, my dependent variable, A of W, is ultimately going to be, kind of analogous to the Y value. So this is kind of an X value. This is kind of a Y value. But using those letters makes it a little bit more obvious of what those values refer to. So that was, I think, number 19 from the homework, maybe. This one was also a question that had been brought up in some emails about, how do I do this. Says that what is nice about this one, at least, is that they give you this. You know how to create that. Um, Says at a certain vineyard, it is found that each grapevine produces 10 pounds of grapes in a season. When about 800 vines are planted per acre. It says for each additional vine that is planted, the production of each vine decreases by about 1%. This idea, this is like an actual phenomenon that occurs. If you start to overcrowd crops, it makes them unhappy, and they don't produce as much fruit, or if it's wheat or corn or whatever that crop is, it won't produce um, its maximum. Okay, so they've figured out that 800 is kind of the what we want. Okay, we'll maximize and get 10 pounds if we have 800 vines, but adding another vine starts to reduce um, the amounts of grapes per vine. So what we're getting here is we're trying to find the amount. So the number of pounds of grapes produced per acre is modeled by this. Okay, so that's a poundage, where N is the number of additional vines. Okay, so pounds per additional vines. Um, so then 800 plus N, 800 is the initial amount of vines, plus then I'm going to start planting extra vines. They're saying for every additional vine, I'm losing 1%. Okay, production from each vine. So this binomial here, this 800 plus N, is number of vines, and this here is the poundage that I am getting in grapes per vine. So if I want to know total amount of grapes that I'm going to yield out of each acre, it's number of vines times the poundage that each vine is going to provide, and that should give me my total. So that's why we're multiplying those together. Um, this would be a much more difficult process if we had to come up with that formula by itself, and we will eventually. But we're looking at that, and we say, okay, if I want to figure out how to maximize this grape production, I need to take this A of N, which is in this format here, and I need to actually expand it. I need to multiply it out, FOIL it out. Okay, so 800 times 10 gives me 8,000. 800 times 0.01 is 1/100th. So 800 times that just gives me 8. That's negative, so minus 8n. Then I get positive 10n. And then when I multiply last times last, I get negative 0.01 n squared. So my formula here, A of n, is equal to 0.01 n squared plus 2n plus 8,000. Okay, so now we want to figure out, how many vines do I end up with to maximize my yield here. So we're going to say n is equal to the opposite of b over 2a again. So we go negative 2 divided by then negative 0.01. I like to look at it this way. So a negative divided by a negative multiplied by that reciprocal gives me 200. Sorry. Yeah, 200. Oh, I messed up. 2a. I just put it over a. So 2a would be, get rid of this. So the a was negative 1/100th. 2a would be negative 2/100ths. But the 2 is going to cancel out. Multiply by the reciprocal, I'm going to get n to be 100. Okay. So that tells me the additional number of vines that I could plant. Okay. It says find the number of vines that should be planted to maximize grape production. N, remember, saying here, N is the number of additional vines. They want to know, find the number of vines that you should plant. Well, 800 was what we started with. We're going to add 100 to that, and we should plant 900 vines. 900 vines will actually maximize my grape production. Now think about this. 900 vines means that each vine itself is not going to produce the 10 pounds, because we're saying that after 800, this 10 pounds gets decreased. But adding 100 vines compensates for the 1% that we're losing per each vine. Okay. Now, if I plug that 900 in, a couple different places you could do it. It might actually be easier to plug 900 in up here to where we get 1700 there, and then multiply that by 10 minus 0.01 times 900. Okay, so it's going to give me, what, 9? Okay, so 1/100th times 900 should give me 9. So multiplying that out, that should give me then the, oh, I messed up again. Just thinking this doesn't make a whole lot of sense. N was 100. N was not 900. If I plug in 100, see, that makes sense. My poundage here would be, my vine would be making 1 pound of grapes. That doesn't make a whole lot of sense. If N is 100, so we got 900 vines in per acre. Then I get 10 minus, well, 1/100th of 100 is just 1. Okay, so 1/100th times 100. Those cancel out, it leaves me just 1. So I get 10 minus 1 here. 9, starting off with 10 pounds of grapes, and then reducing it down to 9, basically each vine producing 9 pounds of grapes, is a little bit more feasible, a little bit more logical than what I had earlier when I had 1 pound of grapes over here. So it gives me 900 times 9, so it gives me a total production of 8,100 pounds of grapes. Okay, so think about it this way: if I left it at 800, okay, 800 times 10 pounds is 8,000 pounds of grapes. A less amount, right? So what we figured out is that by adding vines, even though each vine itself is less productive, collectively, because we have more vines, collectively we get more of a production. So this question, I think what people struggle with on this one is that N is 100, and the answer they're wanting for is then the total amount of vines you need to plant, so it'd be 900, so you add 800 and 100. And then obviously they don't ask for this 8,100, but it is kind of nice to think about. This one here, you're taking this piece of wire, you're cutting it into, it's 10 centimeters long, you're cutting it into 2 parts. We don't know how big those 2 parts are, so we'll let one be x and the other one be 10 minus x. And so this distance here gets bent again into this format. Okay, so hopefully you recognize that we're taking this length of x and we're going to break it up into 4 equal parts. So that's x over 4, that side length is x over 4, and so forth. Same idea here. Now the distance is 10 minus x, so I'm going to take 10 minus x over 4. And that's going to be 10 minus x over 4. Now they want to know, what is the collective total area by the 2 squares. So what I'm going to do is I'm going to find that area, I'm going to find that area, and I'm going to add them together. So the area of the square on the left, x squared over 16. The area of the square on the right, okay, it's 10 minus x, right this way, 10 minus x over 4, that quantity squared. All right, so total area in regards to what x is would be that. Okay, now it's kind of ugly, so let's rewrite this as x squared over 16. This is going to be also over 16, but it's going to be 10 minus x, so 10 squared is 100. I get my negative 20x, and then I also get a positive x squared. So what happens here is we've got 2x squared over 16. we have negative 20x over 16, and then we have what ends up being 100 over 16, and that's the area in regards to x. So now just through some simplification, cancel, cancel, leaves me x squared over 8. Both these have a factor of 4 in them, so 5 over 4, so it gives me negative 5/4 times x, and both these again have 4 in them, so it gives me 25 over 4, so plus 25/4. And again, that you do see that matches up with what we had here. Now it asks us to find the value of x that minimizes the area. Think about this function here, x squared is positive, so that if we graph this parabola, it is going to be concave up because it's positive. So it's going to look something like that, and this is going to be a minimum value. So what we do, we're going to say x is equal to the opposite of b over 2a. So the opposite of b would be 5/4 all over 2a, a being 1/8. Okay, so multiplying that stuff together, I get 5/4. I get 2/8 is 1/4. You can multiply by reciprocals, get 4 over 1, and that gives me 5. What I like to do is when I see 5/4 over 1/4, something like that, if the denominators are the same, 4 and 4, then what I'm left with is just the numerators, 5 over 1, which is just 5. Regardless of the technique you use, you still get 5 to be x. Then what we could do if we needed to, we could actually plug that x back in here, get what, 25 over 8 minus 25 over 4 plus then 25 over 4. And what happens there is really nice and convenient. Those cancel out. So the maximum area then would be 25/8. Or sorry, the minimal area of being able to do this, the minimal area would be 25/8 with a x value of 5. Hopefully that helps. We can talk about these again if we need to, but if you're working on the assignment this evening, that might be beneficial for you.